Welcome to qnawire.
Okay, so this is the force diagram for the stack of the books when the two books are excluded from the stack, since those two books are directly in contact with the hands. Therefore, the FB here is the friction between the books. So we know the system is in equilibrium. Therefore, the net force along the y direction should be equal to 0. So we have 2FB minus W is equal to 0. So therefore, W is equal to 2FB. W here is the gravity of the stack of the books. So we know gravity can be equal to N times mg. N is the number of books, mg is the gravity, and we know Fb here can be equal to mu SBF. Mu SB here is the coefficient of the static friction between the books, and F here is the force applied to the books. So if we do some arrangement here, we have N mg is equal to 2 mu SB times F. Eventually you have N is equal to 2 mu SB times F over mg. So we know the coefficient of the static friction between the books is 0.4, and the force applied to the books is 120 Newton. And we know the mass of each book is 0.95 kilograms, and the acceleration of the gravity is 9.8 meter per second square. If we plug in back to the equation with these values here, eventually you have the number of books is equal to 10. Remember, we exclude two books initially. Therefore, the total number of the books should be equal to n plus 2, which is equal to 10 plus 2, and this is equal to 12. So now let's take a look at another force diagram. And this is the force diagram of the stack of the books supported by the hands. And FH here is the friction between the hand and the books. So now we know the system is in equilibrium. Therefore, have Fy is equal to 2FH minus W is equal to 0. So we have 2FH is equal to W. Remember, so now the W can be equal to capital N mg. Capital N here is the maximum number of the books that can be placed in the stack. And FH can be equal to mu SH times F. So we have 2 mu SH F is equal to N mg. So if we do some arrangement here, we have N is equal to 2 mu SH times F over mg. Remember, in the question, the coefficient of the static friction between the hand and the book is given as 0.6. And we know force is 120 Newton. Mass of each book is 0.95 kilograms. And the acceleration of gravity is 9.8 meter per second squared. So now we can plug in these values back into the equation to determine the maximum number of the books, which is equal to 15. So since the lowercase n is less than the capital N here, so we have 12 is less than 15. Therefore, the maximum number of books that can be supported between the hands should be 12. Okay? And this is the answer for this question.